So section 8.3, our last one of the conics, we're only doing the three, parabolas and ellipses and hyperbolas. So we want to understand the geometry of hyperbolas, key features of the equations and the hyperbolas that we graph themselves, write equations for them, translate them, understand applications of hyperbolas. And really, if you just replace the word hyperbola here with ellipses, you're going to see it's an exact match for what we did with ellipses. So, how is a hyperbola a different conic than an ellipse? Well, first of all, hyperbolas are like an ellipse turned inside out. If you could cut an ellipse down the middle and then turn it inside out, you've got a hyperbola. And that happens because instead of talking about addition of the distance from the focus to a point on the ellipse and back again, we're talking about subtraction. So a hyperbola is a set of all points in a plane whose distances from two fixed points in the plane, again called the foci, have a constant difference. So the fixed points are the foci of the hyperbola, and the line through the foci is the focal axis. Today we're going to find out that apparently whoever it was that decided to study ellipses as a conic was a totally different person at a totally different time than the person who studied hyperbolas, because they don't use the same vocabulary. You know, they change from major axis, minor axis, semi-major axis, semi-minor axis to different language for a hyperbola. It also could be they just decided to do that because it is such a different figure. So the point on the focal axis midway between the foci is called the center. And the points where the hyperbola intersects the focal axis are called the vertices of the hyperbola. So most of the time we do still just talk about them as vertices and covertices, but in hyperbolas, the word covertices is never mentioned. It's better to think of them that way and talk about them that way, so that you can use the same knowledge that you had with ellipses and kind of transform it over to hyperbolas. So here we have the center. A units out, we'll find the vertex. C units out, we will find the foci. And again, we have the focal axis for that one, where standard is going to be a horizontal hyperbola. And over here, they give us a graphic of why this is working the way that it does. That we have these two foci, and we have distances to a point on the hyperbola. But what stays constant this time is subtraction. So if we were to take the distance from F1 to P and subtract P to F2, that will stay constant whether or not we're talking about this point or this point. Right here. So we are not going to be shocked when we see this formula has subtraction in it instead of addition. So as we start thinking about the different conics that we've learned, and we want to know how do we tell the difference between them when we see them, and it doesn't say, hey, this is an ellipse, this is a hyperbola, this is a parabola. Remember, parabolas only have one of the x squareds or y squareds. Ellipses have both, but they have addition. And hyperbolas are going to have subtraction. Yeah.
So you're not saying that the lines between the foci and the point P is going to be equal, but the proportion is going to be the same?
That subtraction will always be the same, right? For any point that's on the hyperbola, as it extends forever, that will always end up being the same. Alrighty, so we see we've got our horizontal, which again, it's the standard form, so we've got x squared, y squared, a squared, b squared, everything seems to be lined up nice. And then we look at, well, what's going to change that so that this would be a vertical hyperbola instead? And with hyperbolas, it's the location of x and y that are going to change. So if the y squared comes first, we have a vertical axis. And we do see the new piece here, which is just a new word for that focal axis. It's called the transverse axis when we talk about hyperbolas. Now, in hyperbolas, a is not necessarily the biggest number. That was just an ellipse thing. So we can't use that as our guide for A and B. What we have to do is remember that it's the x and the y that switch positions when you're talking about hyperbolas. So in a hyperbola, C is greater than A. Well, it has to be, because the hyperbola has to wrap around the focus, and the focus has to be out here. So here are your vertices at A, but C is actually outside that, so your hyperbola gets to wrap around those two foci. Because these formulas have subtraction in them, we should not be shocked to see that if something is missing for us from a hyperbola, we're going to have to use a plus in the formula to find it. So C squared equals A squared plus B squared. Again, A is no longer the bigger of the two denominators. A is always under the first term. So when we have that subtraction in the middle, like it's supposed to be, this will always be A squared right here. So a little bit different thinking than ellipses. Down here we get to see each of the two. So we have a horizontal one. Again, it drives me nuts there's no arrows there, but we know there's supposed to be arrows and it's going to keep going. So we have our vertices, and this is what I said, they don't talk about them as covertices. Notice they didn't even put the B on here up and down. We're going to. It's a big part of how to graph these. But for whatever reason, like I said, somebody was studying it in a different part of the world, and they said, I'm just not going to do that. I'm not going to talk about those covertices. We will. So here are vertices wrapping around the foci. New stuff. Asymptotes. Of course we have asymptotes. We're talking about hyperbolas. That's a big part of hyperbolas, is knowing where those asymptotes are going to be. And we get some new little formulas for those. In fact, this one says b over ax, and this one says negative b over ax. And sometimes students get a little worried because they're like, well, now I got to memorize another formula. No. As we draw these, you're going to realize if you just remember rise over run, not a problem. You don't have to memorize b over ax and a over bx, because it reverses when you go over to the vertical over here. So once we understand the geometry behind it, that's just going to come. It'll follow. We'll know it already. So some of the definitions, some new vocab. Not a new one for this one. This is a chord, a line segment with endpoints on the hyperbola. Still going to be a chord. The chord that lies on the focal axis, and this is going to contain our A values, so it'll be 2A. Again, this is a new one, transverse axis. So we can think of it as the funny name for major axis, because that's what it is, transverse axis. The chord through the center that's perpendicular to that deals with B. So that one is called the conjugate axis. So again, we can think of it as major and minor axis, but it has new fancy names, transverse and conjugate axis. The number A gets the fancy name semi-transverse axis. Again, think of it as it's what we need for the vertices. And then the number B, the semi-conjugate axis. So transverse is the main axis, and then conjugate is like our minor axis for ellipses. So it's just new vocab. Anybody need more time for writing down any of the new vocab? All right. There's our big chart. But we learned with the ellipses, it's not something you need to memorize. What you need to do is understand that for hyperbolas, we have x squared minus y squared for the horizontal, and then y squared minus x squared for the vertical hyperbolas. And of course, it has an x squared and a y squared, but it has subtraction. That's what separates it from ellipses. And then the focal axis, if it's centered at 0, 0, is either the x or the y axis. And as you go through these things, you realize, yes, new names, not major axis anymore, semi-transverse, but it's still A. And semi-conjugate axis is still B for the minor axis. but we need to use c squared equals a squared plus b squared because the initial formula already has subtraction in it. So if something's missing, then we have to change it to a plus. And like I said, the asymptotes, some people memorize them, but you don't need to, and you'll see that when we graph our first one. So y equals plus or minus b over ax, and y equals plus or minus a over bx for the second one. So how do we get these graphed? We are going to make perfect hyperbolas that can be graphed from the formation of a box. So number one is how to sketch those hyperbolas once we recognize they're hyperbolas. Sketch the line segments x equals plus or minus a, y equals plus or minus b, and complete the rectangle that they determine. So if we figure out, hey, x squared is first, this is going to be a horizontal one, I need to go a units horizontally. Then we'll look for b squared and figure out b, and go up and down b units. That creates a rectangle, a little box for us. So once we have that, we can put in the asymptotes. And if you're saying, well, we don't even know where they are yet, we do, because the asymptotes are always going through opposite diagonals of our box. Now, it's not going to be solid. Notice they put those in red. We know not to do that. We know we should do dashed or dotted when we're doing our boxes. But what this does is it gives us the asymptotes for our hyperbola. We already know where the vertices are supposed to be because we graphed A. They're right here. And because we already know what asymptotes do, we can just draw in our two branches right away. They'll go through the vertices and they will approach the asymptotes. So we're going to use that rectangle and asymptotes to guide our drawing. Now, we have, find the vertices and the foci of the hyperbola 4x squared minus 9y squared equals 36. So, I think we've done enough of this with ellipses that you can probably tell me what we have to do to make that look like it's in standard form. What do we do? Every term by 36. And of course we do a little reducing as we go through there. Looks like so. And because I see the subtraction in there with the x squared and the y squared, even if it said, you know, we don't know what this is. Of course they told us it's a hyperbola because we're just starting. But we notice the x squared is coming first, so we should think to ourselves right away, horizontal. Oh, and then I wrote a 4 down instead of a 9. Right here. There we go. A squared will always be underneath the positive of the two x squared or y squared. So a squared is 9, and that means a is going to be plus or minus 3. B squared is 4, so b is going to be plus or minus 2. A always goes on that transverse axis, the major axis. So even if A ended up being smaller than B, which it can with hyperbolas, that's the one that goes on your major axis, your transverse axis. So this one doesn't have an H and K. It's centered at 0, 0. We're going to go right and left because it's horizontal, 3 units. I'm just going to put a little V there for vertices. Now it did say find the vertices, so we might as well take a second and write those down at plus or minus 3, 0. Then we're going to use the conjugate axis, which again is like the minor axis, and go up and down 2. Now, they don't ask us about those. I'm going to label it CV for covertices. But typically with hyperbolas, they just ask you about vertices and foci, again, because they don't give a name to those covertices. So now I'm going to go ahead and do the graph, and then I'll come back and talk about those foci. This is where my box is formed. My rectangle. And that rectangle is what I need to draw in my asymptotes because, again, they go through opposite diagonals. So do the best you can to try to get it to go through 0, 0. and those opposite diagonals. And that's all I need to draw my hyperbola, because I knew it was horizontal, I know it has to go through the vertices, and I know what asymptotes are supposed to do. Asymptotes are things we approach, lines we approach, but never cross. And there it is. So we're looking at absolutely perfect hyperbolas when we can graph them in this form with our nice little box. Now, last thing to do, said they wanted to know where those foci were located at. And I'm actually going to add asymptotes to this list. In fact, let's add asymptotes right now. Remember I said you don't have to memorize the B over A or the A over B. And that's because, by now, we all know rise over run. So all you have to do is think, okay, how do I go from 0, 0 to this little corner of my box here for my asymptote? I'd have to go up 2 and over 3. And there it is. That's not memorizing a formula. Of course it is B over A, but it's not memorizing a formula. And now we need to figure out where the foci are. And what I know is they're out here somewhere. You know, that's what we know, because it has to wrap around those foci. But I also know that because hyperbolas have a minus in their formula, if something's missing, I have to use the plus. So c squared, and we have a squared and b squared right here. 9 plus 4. So c is plus or minus the square root of 13, which we can't simplify. But you might want to see right where they would be so we can get a look at that. So we're looking at 3.606 or so. .606 about there. Just so we have them graphed. And then they did want us to write down where the foci actually are. And they're on that major axis, which is called the transverse axis for hyperbolas. So plus or minus the square root of 13, 0. So there's vertices, foci. We overachieved and put the asymptotes on there to get a little practice with it. But once you have that box, the only way you can mess up is by forgetting whether or not it goes horizontal or vertical. You know, that's really the only way you can mess that up. So now, finding an equation and graphing a hyperbola. Find an equation of a hyperbola with foci at 0, -3, and 0, 3. First thing I do is put those on there. Now that tells me this one is centered at 0, 0, which is pretty nice. Also tells me this is going to be a vertical hyperbola because my foci, my major axis, my transverse axis is vertical. So I start thinking about the good stuff I would need in order to write an equation for it. And I realize, well, I now know c is 3, but that's not enough. So I keep reading. Conjugate axis has length of 4. Well, the transverse axis is the major axis, and the conjugate axis is the minor axis. So if it has a length of 4, that would mean we have to go 2 in each direction. And again, they don't call them covertices, but we are going to, so that we have an idea of what's going on. Well, that tells me B. B is 2. Now, we need A. I mean, that's a pretty important part of our little box. So, because there's subtraction in the formula for a hyperbola, we have to use addition to figure out what our A value is. So 3 squared is 9, and 2 squared is 4. So we've got plus or minus the square root of 5 for A. They do want us to draw it, so we probably want to think, well, I know it's 2 point something, but what is it? 2.236. Whoops. It's right over the top of that and make it a little V right there. So we have our A value. We could go ahead and write it. We might as well finish up the graph while we're here. We can make our box. Put our asymptotes on. And then again, it's hard to remember that you got to keep that vertical piece in your head the whole time, because unfortunately, when we get to the test, every once in a while somebody goes ahead and graphs these horizontal. So it goes through the vertices and approaches those asymptotes. Well, let's see if we can write it. So we have y squared over, well, the square root of 5 squared would be 5. Minus x squared over 4 equals 1. So there we have the first part of this problem done. Find an equation of a hyperbola foci at 0, -3, 0, 3, whose conjugate axis has length of 4. We sketched it. The one thing we didn't do yet is the asymptotes. So I know it's y equals plus or minus something, and again, I just come over and say, how would I get from 0, 0 to this upper right corner of my box? I had to go up the square root of 5 and over 2. And you have it. So that box is going to help us do everything that we need to do as far as hyperbolas go. Now, of course, we're going to translate it. So now we're going to add the h and k in there, just like we did with the ellipses. So when a hyperbola with center 0, 0 is translated horizontally by h units and vertically by k units, the center of that hyperbola is going to move from 0, 0 to hk. Such a translation does not change the length of the transverse or conjugate axis or the Pythagorean relation that we use to find things that are missing. So now we're just adding in that x minus h and y minus k. Again, this one is one where students tend to make more mistakes because we want to put h in this first position. We're so used to that. But if it is vertical, we're going to have to make sure that we have h is with x all the time, k is with y, and just make sure that we stick with that. Now, again, this looks much more complicated, but it's really just about understanding how the hyperbola is drawn so that you think, all right, if I have a new center, I still have to go A units on the major axis out from the center. I still have to go B units on the other axis from the center. And it's just a counting thing is really all it is. So this is a great box, but don't let it make you nervous. There it is. And again, looks bad with all of the variables that they have in here. But here's our center. We're going out A units to get our vertices. And then we're going out C units to get our foci. Again, they don't talk about the covertices, but they're absolutely there. They're part of our box that we make for our two asymptotes that we're going to use. So now, to graph or write an equation for a hyperbola with the given features. Sketch and label what you're given. Locate and plot the center. Yeah, that's where we need to start. You know, everything is determined by where's the center of this hyperbola. Determine A, B, and C. Mark them on the graph. Sketch the hyperbola. Make your box. Put in the asymptotes. Determine which direction it's going in, horizontal or vertical. It's in there somewhere. You know, as you first look at it is probably when you're figuring that out. And write the equation if you need to do that, if you're asked to do that. So finding an equation of a hyperbola. Find the standard form of the equation for a hyperbola whose transverse axis is endpoints at -2, -1, and 8, -1, and I'm not even going to read any further. I have to get what information I can from that. So I think transverse axis, let's see, that's the major axis. So the major axis is A, -2, -1. So vertex, and 8, -1. Vertex. Now that just gave me two things, if I can do the math right. It's going to give me the center, because the center is halfway between those two, and it's going to tell me what A is. So I think, all right, what I really care about here is the x values, because halfway between those two is the center. So if I take -2 plus 8 and divide it by 2, I'm going to be at 3. My center will be at 3, -1. That's important. Can't make my H and K stuff without that. And now I can count A, or just look at it and say, well, from 3 to 8, that's 5 units. So A is 5. Also tells me this is a horizontal ellipse, because my vertices, my transverse axis, my major axis, is going to go out horizontally. So now I'm going to go ahead and write down the formula so that I can remember all the things I have to find. And don't forget, this one is based on subtraction. Well, I already have H and K. I know where the center is, so that's a good one. Oh, I have A as well. So all I need is to keep reading in the hopes that maybe they're just going to flat out give me B, or it takes a little thinking and I'll get it. Conjugate axis has a length of 8. There it is. That's my minor axis. So if it has a length of 8, I have to split that 2 ways and go up 4 and down 4. And that is going to change my y coordinates here. I mean, I still am at x equals 3. I just have to figure out, if you go up and down 4, where you're going to be at. So -1 minus 4 takes me down to 3, -5. And -1 plus 4, 3, 3. But really all I needed to know was B is going to be 4. To write it. That was the last piece that I needed to write it. So I'll have x minus 3 squared over a squared is going to be 25 minus y minus a -1 will be y plus 1 squared over 16 equals 1. Well, let's see if there's anything else they wanted while we're here. Find the standard form of the equation for the hyperbola whose transverse axis has endpoints at -2, -1, and 8, -1, and whose conjugate axis has a length of 8. But I got to draw it because it's just going to kill me if I don't. Vertices, covertices. And it gives us a little extra practice at graphing the translated hyperbolas. Uh-oh. Smartboard didn't like that move. And this one was horizontal, so we're going left and right. Our first translated hyperbola. There it is. All right, so we've got it in standard form, exactly like they wanted. We actually found more information that they wanted. If they needed the foci, we'd just use c squared equals a squared plus b squared, and we'd find it. This one is going to make us do that. So this one says locating key points of the hyperbola, and we want to graph this one. So find the center, vertices, and foci of the hyperbola. I'm going to warn you before you get ahead of me too far, because I know at this point some of you are already, you've got this and you're going through it. On this one, We're going to have to change the y-axis to go by 2's to fit this on there. I don't want you to find that out after you've already got everything graphed on there. All right. Do you see why? Do you see how I know that by looking at it? Yeah, you found the 7. Okay, good. So, help me out. Horizontal or vertical, this one? Horizontal. The x squared is first. And the all-important starting place, where will our center be? Good. I'm going to get that on there right away. And again, don't forget that we had to go by 2's. Alrighty, so what's a? Not a squared, what's a? I know you can go to that right away for me. Plus or minus 3. And since this is horizontal, we need to go from our center 3 units right and left. And what's b? 7. So we're going up and down from our center, 7 units. Be careful because you're going by 2's. And you can make your box. And it was horizontal, so we're going left and right. But we have to formally write down, we've got the center. Now we're going to formally write down those coordinates for our vertices. And then we'll figure out the foci. All right, so we had a center at -2, 5, and we had to go left and right by 3 units. So that means the x is going to change. -2 minus 3 would give us -5, 5. And -2 plus 3 would give us 1, 5. And we've got them graphed, so I suppose you could count it too, taking a look at all of that. And again, they don't refer to covertices with hyperbolas, so they're not asking us for that. But they are asking us for the foci. So, c squared equals, what do we use with hyperbolas? Plus. So we've got our 9 and our 49 up there for a squared and b squared. C equals plus or minus the square root of 58. Time to stop and think perfect squares. We have anything that's going to go into 58? We're stuck, aren't we? So this is where it's really important that we remember they have to be on that transverse axis, that major axis with our center. So that's going to be affecting the x coordinates. So we're going to have to take -2 plus and minus the square root of 58. And let's see, we were at 5 for the y coordinate there. So transverse axis is the major axis, conjugate axis, the minor axis. And, let's see, the one thing that worries students about these translated ones, again, is going to be asymptotes, which we typically don't ask outside of the homework anyway. But notice how you're still just going to find the slope by counting in your box. All you have to do is make sure that you do that translation of x minus h plus k, and you've got it. So it truly is find the slope and do your h and k pieces in there. What do you think? Pretty good? Feeling good about them? Okay, good. 3 conics that we've covered. And there's some practice. Oh, I bet I better sanitize and get you some graph paper. That'll make that go faster. Let me double check. I think it's the little paper that'll work really well for this.